what do I have to do? 3 times 1 is 3. It goes on top. 5 times 2 is 10. It goes on bottom. You would reduce it if you can. You cannot reduce 3/10, so you just leave it. All right, so multiplying is just multiply straight across, right? So we just multiply straight across for that. That's all we have to do. So whenever I see a problem like x squared plus 2x minus 8 over x squared plus 4x plus 3 times 3x plus 3 over x minus 2, it's really like just almost like one big problem because you would just multiply everything all the way across, right? So over here, I'm just going to take each piece at a time and try to factor it. So, x squared plus 2x minus 8. I'm going to have 2 sets of parentheses. I'll have an x here and an x here. What number should I use to get negative 8? What signs? I've got negative 8 that I'm trying to multiply to get. I got positive 2 that I want to add to get negative 2 and positive 4, right? So positive 4, negative 2. All right, in the bottom of that fraction, I've got x and x. I want to multiply to get positive 3. I want to add to get positive 4. What numbers could I use? Positive 3, positive 1. So plus 3, plus 1. Okay, so that's my first fraction. Then my second fraction, I've just got 3x plus 3. Is there anything I could do to that? I can factor out the 3. It has the greatest common factor, right? So I can take a 3 out. So I'm dividing both of those by 3. It's just going to leave me with x plus 1 inside of the parentheses. What about x minus 2? Can I do anything with it? No. Let's put it in parentheses because it is a factor there. Okay. And to multiply fractions, we just multiply straight across, so we can treat this like one big equation, right? So first of all, we should do our excluded values, I guess. Let's do those. What can x not equal? We're looking at the bottom. What would make this 0? Negative 3. What about x plus 1? What would make that 0? What? Negative 1. And what would make x minus 2 0? Positive 2. Okay? So, now that we've got our excluded values, we're going to start marking out. So I've got a x minus 2 here and an x minus 2. Those will cancel. I've got an x plus 1 and an x plus 1. Those will cancel. Will anything else cancel? No. You might be like inclined to cancel this 3 and that 3 right there, but it can't be done. It'll kill a kitten if you try because there's a plus sign between the x you would be separating it from. So, on the top, we typically write that 3 first and then the x plus 4. And then on the bottom, we've just got x plus 3. So it is really like just a bigger version of the problems we've already been doing, right? You're factoring, you're looking at excluded values, you're canceling out. Okay. Students who can factor well do well with these problems. Students who cannot factor have trouble. Hello? Yes, thank you. Alex, you're going to go join your friends in the office. Hopefully no more of us have to go. Okay. All right. Let's look at example 2. All right. So just like the last one, we are going to factor. In the top, we'll have 2 sets of parentheses here. I'm trying to multiply to get negative 9. What am I adding to get? Nope. Is there a middle term for that one? 0. And when that's the case, I'm using positive and negative of the same number. What numbers should I use? Negative 3, positive 3. It's a difference of squares. So you got an x here, an x here, plus 3 minus 3, or minus 3 plus 3, either way. Okay? In the bottom, I've got a 6 as my last number. I've got a 5 as my first, so I'm multiplying to get 6. I'm adding to get 5. Both of those are positive. What number should I use? Positive 3, positive 2. So plus 3, plus 2. X plus 2, can I do anything to that? I cannot. I'm just going to leave it in parentheses. What about 3x minus 9? I definitely can't factor it in 2 sets of parentheses. But, Angel, is there a number I could divide both of those by? The 3x minus 9. So, 3x and negative 9. What can I divide both of those by? What? 3. Alright, so, we'll pull 3 out. This is all multiplied. We got x minus 3 right here. So, we want to do our excluded values. X cannot equal. We're using opposite signs. Did they let you go already? Okay. Do you play sports? Do you drive? Huh? Because if you drive, I think you have to be. If you don't park here. All right. All right. Okay. Questions so far? Now we can start marking them out. X plus 3 marks out. X minus 3 marks out. X plus 2. Almost everything is gone here, right? The only thing I have left is the 3 in the bottom. I cannot have a fraction with nothing on the top and a 3 in the bottom. What do I have to put on the top? 1. So it's going to be 1/3. It's kind of neat because, no matter what number you plugged into that, it would give you 1/3 every single time. Except for -3, -2, and 3, which would give you a 0 on the bottom. All right. Questions? Let's fill in these words, but we've really already been doing this. A restricted, I've actually used the word excluded there because that's what our worksheet said. Is any value that makes the denominator of a fraction. Got to be kidding me. Hello? Yes, thanks. Alex, I need you again. All right. The denominator of a fraction is equal to 0. Is a restricted, or you could use the word excluded value. Now, we have already done a couple of these, which I think is going to be sufficient for today. So we are going to skip over this. We're going to go to dividing. Now, dividing fractions. How do you do it? It is the opposite. Keep, change, flip. Keep, change, flip. That definitely works there. So you keep the first fraction. You change the sign to multiplication, and you flip the second. Or, my favorite phrase for this one is dividing fractions. Easy as pie. Flip the second. And multiply. Okay? So, if we are asked to simplify this, a plus 2 over a plus 3 divided by a squared plus a minus 12 over a squared minus 9. Dividing fractions is easy as pie. Flip the second and multiply. So the first one stays the same, a plus 2 over a plus 3. We're going to change that division to multiplication, and we're going to flip the second fraction. So it's a squared minus 9 over a squared plus a minus 12. And now we just have a multiplication problem, which is what we were already doing, right? So a plus 2 and a plus 3, you can't do anything with them. You're just put them in some parentheses there. But over here, how could I factor a squared minus 9? I have an a and an a. What numbers could I use? We just did this one. Plus 3, minus 3. In the bottom, I've got an a and an a. I'm multiplying to get negative 12. I am adding to get positive 1. What numbers could I use? Which kind of 3 and 4? Positive 4, negative 3. Very good. So plus 4 minus 3. Okay, so I want to do excluded values first. Division ones are a little bit tricky. You need the bottom of this fraction, which is going to be a cannot equal negative 3. You need the bottom of this fraction, which is going to be a cannot equal negative 4, and a cannot equal positive 3. You also need to look at the top of this fraction as well, because it flipped. So at no point can your denominator equal 0. And this was the denominator of the second one in the beginning. So, but these are going to be negative 3 and positive 3, which are already listed, so you don't have to list them again. Sometimes they're not, and you need to list some more numbers. So that's for excluded values. Then we just start marking out. A plus 3's will cancel. Our a minus 3's will cancel. And for this, we will just have a plus 2 on the top and a plus 4 on the bottom. And that'll be our answer. Okay, questions? All right, I want to do one more before it's time to go. And I want to do this one. These are so fun. Okay, don't you just love the look of that one right there? These are called complex fractions. They are fractions inside of fractions, as if a single fraction was not enough. But complex fractions are really just division, right? You got a fraction on top divided by a fraction on the bottom. So if you don't have to do it, but if you want, you could do b squared over 25a squared minus b squared divided by b over 5a minus b. If that helps you, you can write that step. I usually don't write it. I go straight to the flip and multiply, but you can. So dividing fractions is easy as pie. Flip the second and multiply whatever's on the bottom as your second. So that's going to give us b squared over 25a squared minus b squared times 5a minus b over b. And so there's not really anything you can do with the b squared. But on the bottom, we can factor this. To get 25a squared, we could do 5a and 5a. And then to get b squared, we need to do a positive b, a negative b. If we multiply that back, then we get 25a squared minus b squared. And there's really not anything you can do over here either, except for I am going to put this in parentheses, and I've got a b here. Now, your restrictions on this are really weird, because definitely b cannot equal 0, because this denominator right here cannot equal 0. But you're also going to have 5a plus b cannot equal 0, which means you like subtract. Actually, just leave it like that, because you've got an a and a b, which just makes it weird. And 5a minus b cannot equal 0. Those are weird restrictions. You're not going to see that very often. Okay, so we can start marking out. 5a minus b is going to be gone. Anything else I can mark out? All right, this b squared right here is really like having b times b. So I can take one of these b's and mark it out with this b over here. Okay, and so that is going to give me, on the top, I've just got a b. On the bottom, I've got 5a